We'll do a few introductions. We'll go over the basics of how scripting works within Workbench, and then a brief section on what it can and cannot do. It's really important. We'll talk about how it's documented in the Application Programmer's Interface. We'll go through a couple of examples, and then I've got some suggestions and recommendations based upon what we've gone through with the tools. So introduction-wise, we're down with this one, we're down to webinars from the restart after our summer break. Next week, or next month, in September 8th, we've got office hours with PADT. I'll talk more about that on the next slide. And then we've got one on the 22nd, which is using Excel with Workbench. We'll talk about all the different ways that Workbench interacts with Excel and vice versa. I've got tentatively scheduled, I haven't decided yet, that we'll do external connections on October 13th. So that's basically an extension of Python scripting, really big time, and also some XML files that allows you to take your own solver and hook it up to Workbench. And I'm thinking of finding, I got an electrostatic solver that we used to use that's open source that I might hook up. So we'll see if we have time to do that. But that's what's scheduled for the 13th. And then October 27th, we'll start our 14 webinars. I think it'll be cooked enough by then to go over what's important in our 14. And then we'll follow that up in the new year with some specific ones in different areas. This will be kind of an overview of what's cool and new. Do always go to the website, padtevents.webex.com, to learn more and to look at recordings of previous webinars. So what is this office hours thing we're going to try and do next month? It's questions that go beyond tech support. Ask us about a new feature, get some advice on something, and general questions about Ansys products. We've only gotten actually 2 questions. So if you were hesitating, thinking, oh, they got a bunch of questions, I won't send mine in, please do. We didn't get as many as we expected. So you send them to officehours@padtinc.com, and Doug Otis, who came up with this idea, has been tasked with filtering those, and we'll answer them 5 to 10 minutes. If we don't get enough, we'll pick a couple of small topics that aren't long enough to fill a whole 45 minutes to an hour and add those in there. So they just need to be questions that you send in before the end of the month here. Not your tech support questions like my install doesn't work, but I can't get this model to converge, or hey, I know there's joints in Ansys. What do they do? That sort of stuff. And we're looking forward to it. We hope that's something that'll grow over time, and we'll get more stuff. About us, we're an engineering services company located in Tempe, Arizona. We're all mechanical engineers, or mostly. We've been around for 17 years, and we have 68 employees with 3 business areas. I mentioned that Award and I share responsibilities for the CAE sales and services part of the business. That's where we do consulting, training, and sales and support built around the Ansys product line, as well as Stratasys printers and production systems. We also have another group that does product development, which is basically design, test, and prototype build for devices, mostly semiconductor equipment, medical devices, and alternative energy. And then our wrapper prototyping and manufacturing group, we have in-house most of the major prototyping technologies, and we also assist people on a consulting basis with manufacturing. So do go to our quite antiquated website and check it all out at padtinc.com. I also want to put a plug in for our systems that we sell. We built our own computers for quite some time, and we had customers ask us if they could get one, and they're very affordable. As an example, you get 96 cores and 256 gigabytes of RAM with a UPS and 3.6 terabytes of disk for $43,000. We have smaller machines that are more suited for mechanical rather than CFD. We have bigger machines for large CFD problems. So do check that out. We just sold 2 to a company in Florida that we're really excited about because one of them uses the new Intel chips. And the price is quite a bit higher than what you see here because those chips are pretty expensive. But it's a really fast machine. We're putting it together right now, and we're really excited about it. So if you're looking to buy some hardware and you convince your IT guy not to buy from Dell, give us a call. Also a plugin for Pedal, which is our APDL editor. We're talking about Python today, but if you still use APDL, do download this and give it a try. Get a 30-day trial on it. And it's a great tool for creating APDL scripts. Even if you're a Workbench user, if you're writing APDL scripts for Workbench, it's a nice tool. And feel free to connect with us in a lot of different ways. Facebook, you can manage your subscriptions. You can follow us on Twitter. We don't have a lot of followers there. It doesn't seem to be popular with mechanical engineers. Of course, our website has been there. Link with us on LinkedIn, and most importantly, and in the bottom right corner here is the focus. If you're not subscribing to it, it's kind of the detailed follow-on to these webinars. We have almost every week we publish some sort of an article there that has lots of good information in it. In fact, we'll go over one of the examples today came from an article on the focus. So let's get started. We're up to 45 people. I think we got a quorum here. So I'll probably go for about 45 to 50 minutes now. If you have any questions, just type them into the either the question tool within WebEx or the chat tool within WebEx, and I'll answer them as I read them. So how does scripting work is what we're going to talk about first in Workbench. So the original Workbench, you've heard, if you've been to these webinars before, you know it's very confusing what's Workbench and what isn't Workbench. The original Workbench, what was Design Space and simulation and now Ansys Mechanical, didn't include any scripting or journaling. It's what Ansys Mechanical is written in. It's a huge departure from the APDL-based product that is now called Mechanical APDL, what we used to call just Ansys. And in my opinion, it's the biggest deficiency of these tools. I really like these Workbench-based tools, these original tools. They save hours and hours of time and geometry and meshing and applying loads and things, but I miss the scripting. And there's a lot of things that I want to do with scripting that's not there. So it's always been a kind of a sore point. So when they started and said, okay, well, that's actually, we're all getting old. That Workbench infrastructure, the original Workbench, is getting quite old. It's time to do a new one. They from the ground up have decided to make it journaling and scripting. They learned their lesson basically from listening to people like me on the advisory council scream and yell about wanting their scripting, and then when they acquired CFX and Fluent, which have scripting, they had the same opinion. So when you have this journaling and scripting, everything you do in the graphical user interface, the GUI, can be captured to a file, and then you can replay it or make your own file and run it. So if you build a program to have this built in, this is what you get from it. Now, they decided to use Python as their scripting language. It's kind of the dominant scripting language out there. And in fact, the new Workbench interface, what Project is written in and these other tools, is assembled using Python scripting. So that's how they define it and manage it. Python is the most commonly used non-proprietary scripting language in the CAE world. Many of our competitors use it for their scripting language. It is object-oriented, so it's modern. It's very well documented. There's tons of websites, and there's tons of libraries and add-ons that people have written for it. So it's got a great breadth and depth of capability. And most importantly, I think, is that it can be integrated easily with other development libraries and languages. So you can make it work with .NET, with C, C++, C#, whatever. So if a tool uses Python, the other thing that's nice about it is that the tool can create a Python shell that interacts with it. So users can send a Python command to that shell, and users can also run scripts through that shell. It's kind of built in. So that's kind of a nice benefit as well. Whereas something like Mechanical APDL, they had to write their own shell and their own interpreter. It kind of comes with. And I got a question about, is this a portable tool? Yes, it's very portable. The Python itself doesn't really care whether the Python interpreters have been written for Linux and Windows and the Mac. What they're connected to is what's important, and in this case, Ansys is writing the new interface to be much more portable to Linux than the old Workbench. So it'll be much more robust. So yeah, you don't have to worry about the fact that I wrote it on Windows and it won't run on Python. So that's good. Let's talk about what journaling is. There's a lot of names for it. You can call it a log file, a session file is what we called it in Mechanical APDL, a command file. But basically what it says is when a user does something, it executes a command, the command is converted to a script command and written to a file. So sometimes in a command-driven program like Mechanical APDL, it actually writes the command, right? But in a program that is object-oriented like Workbench-based programs, what it does is it says, okay, well, he did A, B, and C. I'm going to give him the exact same Python calls that do the exact same thing. We call it the session file, the .log file in Mechanical APDL. But it's very different for these reasons. APDL is command-driven. In APDL, the GUI generates a command, it sends it to an interpreter, and the interpreter sends them to subroutines. With a journal, there's no command layer there. It's all objects. So the journal is a record of what is done and can be replayed. And then the interpreter converts the journal to commands that are made calls. So it's a subtle difference, and it doesn't matter to much users, but to developers, it's a huge difference on how it works. So how do you turn on this journaling? It's been there actually for a few releases. The way you turn it on is that you go in the project page, you go to File, Scripting, and Record Journal. And you specify a file, and the extension they've picked is WBJN for Workbench Journal. And you specify the location. There's no default. And I haven't found it in the Files window. Maybe I just missed it, but I don't think it's tracked in there. And you do your stuff. You do whatever you're going to do. And then when you're done, you go back to File, Scripting, Stop, Recording Journal, and you hit Stop. This will change to it. Where it says Record Journal, it'll change to Stop Recording Journal. And you turn it off. There's no icon right now there. They're going to offer more customization of these toolbars at R14, and hopefully we'll be able to add a record start and stop button with that. So let's do actually I got a question here. Does Python replace APDL? No. APDL is there. It's going to be there. The core Ansys mechanical APDL solver product will never change. You know, APDL is how that program works, right? What we'll talk about a little bit, I think, I'm not sure if we get to it or not, I can't remember if I ran out of time, is how to send APDL commands through Python to mechanical APDL. So you can still use Python to drive the program, but you still got to create the APDL commands. And there's a ton of users that do that now, and you'll be able to do it through Workbench as well. But no, APDL is not going anywhere. It'll be here until probably they find a replacement for that solver, which is not planned or scheduled or even makes sense. So the simplest example that I like to show is changing the density in a model. So we're going to start with this really simple mechanical system. I've got my geometry system. I've got my actual structural analysis here. I've got some parameters defined, so I've got a parameter set in here. And what I do is I go to File, Scripting, Record Journal, like we talked about in the previous slide. And I specify my file name, change density 1.workbench journal. It shows up in a weird system directory, so it does not default to the project directory. Be aware of that. I did this and I couldn't find my journal file. I'm like, so be aware of that. Then you right mouse button on the thing you want to change. In this case, I'm changing material property, so I'm going to right mouse button on engineering data and say edit, just like I would normally if I was going to do it. And then select the material that I want to modify in the outline, so my structural steel, and then I go down to the density and I change the density value. And then I say return to project, and then I go back and I go to File, Scripting, Stop, Recording Journal. Really straightforward. And I did that in multiple slides. You may be asking, why didn't you just do an animation? Because we always have trouble with WebEx and animations, so I did that. This is what it looks like if I look in that journal file. It's got a comment in here that says what it's encoded in. Then the Workbench scripting version that it's using is 13.0. And then it identifies the system that I'm messing with. System 1 is the system, that structural analysis system. I didn't give it a name. And then engineering data. So I go and I say, get the system, and it's called System 1. So that's how I grab it, and I get a handle to it called System 1, or an object. And then I say, for that object, get me the container that's called engineering data. And then, so I have that, engineering data 1. And then for that object, I say, get the material that I called structural steel, material 1. That's what I put it in, the object. And then for that object, I say, give me the property, a pointer of the property that's called density. And then I say, with that property, I want to set the data, and the variable I want to change is density, and the value I want to change it to is 8,000. It says 7,000 here, but I changed it to 8,000. And then I save this. Oh, that's what I'm pointing out here is, in order to make a script, this is what's recorded. I changed it to 8,000 interactively. Now I'm going to go ahead and make a script of this. I'm going to change it to 7,000 and save with a new name. And then I'm going to run that script. I'm going to go to, and we'll go back to that script and talk about it in more detail later when we do examples. Execute by choosing File, Scripting, Run the script. So File, Scripting, Run script file. and I basically point to the file and it'll run. And if I go and look at my engineering data, you see that it's changed to 7,000. So that's really cool. Ta-da! I am now a Workbench scripter. That's how easy it is. And, of course, to make your program, you just add a few more lines. It's a very simple example, but the process is the same. You run interactive, figure out, you can look in the help, you can look in the API documentation and try and find these objects and methods and stuff, or you can just do it interactively and have it point them out for you. A lot of times it's more verbose, so you got to clean it up and modify it. And then if you want to add more to it, use the API and documentation, and run the file when you need it. Now, let's a little bit more detail about how it works. There's a couple different versions of Python. They use something called IronPython. It's a commercially supported, that there is a version of it. It's an open source tool, but there's a commercial where you can buy support for it, and it's QA'd. And the reason why they picked it is that it's tightly integrated with the Microsoft .NET framework. So there's a bunch of different Pythons out there, and they have these modules that connect to different things. Since the Workbench infrastructure uses .NET, they wanted to be able to talk to .NET without having to write their own code, which they could do using C++ or C#, I can't remember which. But instead, they went with the IronPython, so they don't have to do all that. And it's a really nice thing. And it also supports the Microsoft Common Language runtime. So you can use Python and with C, with C#, with C++, with JavaScript, with all these different programming languages that Microsoft supports through this CLR, and it allows them to save a lot of time and money doing stuff. So check out the website to learn more. Most people, when they say they're using Python, they're using something called CPython. It was the original one. The big thing to be aware of is that some of the projects, some of the modules that you can add into your Python may not work with IronPython. Python is all about these projects. So before you decide, I'm going to write this thing and I'm going to use Joe's graphing, let's say you want to do your own graphs, extract your parameters and graph them yourself. Well, you can do that, but you need to do it, you need to make sure that graphing module that you're going to use works with IronPython, which is pretty easy to check. So one question I got is, what advantage did Python give you over APDL in your example? Actually, none. It's a lot easier to do in Python in APDL. It's one line. But new applications don't use APDL. Mechanical doesn't, meshing doesn't. A lot of tools in Ansys don't use APDL. So Python is for the new tools. APDL is still there. You can still use it. Another question that I just got was, is Python 2.x or 3.x? It's 2.6 is the current version of IronPython. I have not checked 14 to see if they changed that, but I think it's 2.x, not 3.x yet. I don't think IronPython has a 3x version yet. So something that's built in, like I talked about earlier, is this console, this command window. And you can open it up. If you go to File, Scripting, there's a G there that I left out, Open Command Window. You can actually get the little command interpreter, a Python command interpreter. So instead of running a Python script and looking at the log file or the error message that pops up on the screen, you can paste in 1 to as many lines as you want into this window and get immediate feedback. And I like to do that. I like to go, if I'm extracting a parameter, say, oh, here, I did an example. I typed in var1 equals 37, var2 equals 123.4, multiplied them, and then set the density to that value, and then it printed out that new den value just to see what it is. So it's an interactive way to debug. Can Python and IronPython be installed in one PC in parallel? That's a really good question. So you don't need to install IronPython. The command interpreter for IronPython is built into the Workbench, and it does not interfere with Python. I have both installed on my machine. I've never had a problem with it. So, if you have a really complicated Python script and you're trying to run it, debug it outside of Workbench, maybe it's got a lot of portions to it that don't need Workbench, you should be able to do that. You should be able to install both. It's when you start up the command interpreter, you would point to the IronPython command interpreter instead of the CPython interpreter. So it should work, but you shouldn't have to do it unless you're doing some really serious scripting. Um, what's kind of cool is that a lot of people, and we'll talk about this a little bit later, that don't know, is that you can run Workbench from the command line and give it command line options. You can tell it to run in batch mode, so don't bring the GUI up. And it does start the Python command window, right, because that's how it interacts. You can do -R, which says run a file name as a Python script. You can launch the GUI and use -B, so you get both the command window and the GUI. You can run interactive with the GUI, but exit when your script is done. So if you want to see something on the screen and have it go away. You can specify the Workbench project file, and you can execute a given command, which is a single Python line, basically. So this opens up a lot of opportunities to use Python to control batch runs and things like that. Be aware of that command, and it is documented quite well. So if what I've talked about you is confusing, especially the example where I was talking about the objects and pointers and stuff like that, you need to learn the basics of object-oriented programming first. If you're an APDL guy and a Fortran guy and a C guy, so the three languages I know really well are C, Fortran, and APDL. So object-oriented stuff really hurts my head. So it took me a long time to get my head around it. Python is a great way to learn object-oriented programming because it's very simple and intuitive. But if you're a procedural thinker like I am, don't get discouraged. It can take a little bit more time than you thought, but it is a nice way to do things. And once you get your head around it, it's pretty cool. So that's the basics of how Python works with the Workbench. So before we go further, and some of the questions are kind of addressed by this, is remember that the scripting, this journaling and scripting, only works on the Workbench-based applications, not Workbench 1, not Ansys Mechanical, Design Modeler, Meshing, those things, but only Workbench 2 applications, a new generation of Workbench. And what can I say? They should have changed the name at some point, but they didn't, so we're stuck with this. So for a data-compliant application like Mechanical, Design Modeler, Meshing, which are actually Workbench 1, that's a typo. Let me just fix that. If somebody downloads the thing from the current slide. These are all Workbench 1 applications, so they don't use the Python scripting. They use a different Python scripting, but they don't use this Python scripting. Fluent, ISM CFD, CFX, and Maxwell, they all have legacy interfaces. But the native applications, which are written in the same language and toolbox, engineering data, project schematic, design explorer, and parameter manager, the ones that are available today, they all use this scripting and journaling. And somebody asked this question, is this a replacement for APDL? No, it's not. Or if you're a CFX person, is it a replacement for CCL? You can create an APDL script and feed them to Ansys Mechanical APDL through this tool. There's this send command that they created that says take a string and send it to the command interpreter of whatever program I'm talking to, CFX, Mechanical APDL, Fluent, whatever it is, you can send your commands that way. And you can execute commands in Mechanical APDL from Python. What you can do, and I'm not going to go into this, is you can actually launch Mechanical APDL, opening up a TCP/IP socket and connect to it through Python and drive it that way. It's kind of cool, but we're not going to talk about that today. And same goes for CFX and Maxwell. They have a scripting language that you can work with. So the programs that work with the send command are Mechanical APDL, work with APDL. The Mechanical, Design Modeler, Meshing, and Aqua all use JScript, so you can send JScript commands. CFX uses CCL, and Fluent uses Scheme. So I got a really good question here. Is Workbench 2 coming to simulation to allow this type of scripting? No. There's something entirely different that we're going to allow a higher level, a level of scripting for Workbench 1 applications, simulation specifically. I'm not going to talk about it because I'm not sure if it's going to be beta or not, but it was basically developed internally at Ansys because they wanted to more easily script it, and they wrote an API on top of JScript, which is what Mechanical and Design Modeler and those use, that can be called from Python, and it allow you to do a lot of things that people want to script. So we'll have a whole other session on that in probably about 3 to 4 months once that's released and we understand what is going to be released and what's not. We've used it a little bit for some customer projects, and it's nice. It does use Python. And a very valid question that someone else asked, if you already have APDL commands, why convert to Python? There's no reason to. Absolutely no reason. This is for people who want to control their execution through the project schematic or the engineering data, or use Design Explorer to do probabilistics. That's why you would use this tool. If you're just using mechanical APDL, stay with APDL. So what is it good for? So lead in right to the next slide. It's the automation of creation, interrogation, and modification of material properties, project systems, parameters in a Design Explorer. That's what works right now. The most common use that I've seen is parameter management. So I go out and I get parameters and do things, and we did a seminar on this 2 weeks ago, and you can use Python to do some really cool stuff with these parameters that you have control over. And I think the most powerful use is to control your project systems. You can automatically create schematics if you want. You can create custom systems, set properties in systems, and interrogate systems. So that's the more powerful usage of it. It's not an external connection. This is not how you say you've got an in-house code that you want to plug into Workbench. There's something called external connections that uses both Python and XML to connect to the external program and make it data compliant, but it's not the same API. It's the same methods and the same objects, but it's not journaling and scripting. It's run differently. And like I said, we're going to try and do an upcoming webinar and focus on that. Also, if you've attended or read the article, and I think we did do a webinar on design assessment, which is a way to do sophisticated post-processing and load case combinations in mechanical, Ansys Mechanical. That also has a Python interface, but it's not the same thing as what we're talking about here. What you're finding is that the developers and application engineers and channel partners that use the Workbench One products like Python, and so when they've added customization capabilities to these tools, instead of doing it in JavaScript, they've written Python interfaces, and that's what we're seeing here with the external connections and with design assessment and some other stuff that we've talked about in the past. So what is journaled? Not all actions that you do in the GUI are added to the journal file. The only thing that's added to the journal file when you do them in the interface are things that change the project data while you're doing them. So that's how you can tell. So a good question that we just had is, I think on design assessment, is going to be used for those wimpy user output features in mechanical. Yes, that's kind of what they're there for. So if you go back and look at the recorded session on design assessment, we've got some more information on that. And they're improving design assessment as well as this new tool that may be released in 14. And so we'll do some webinars on that as well. So yeah, you can do some pretty cool output stuff using Python with this design assessment. So let's move on to the application programmer's interface, the API. So this is what developers call the part of their code that they let other people look at. It allows people outside of the company to interact with their tools and their software. And they've created these Workbench objects through the Workbench API. And it's also the commands that are created and put into the journal file. And I found the help pretty good. I never find object-oriented help intuitive or easy to use because I still don't think that way. So I still sometimes struggle with it a bit. But it seems to be fairly complete. And those younger people here that work here that are object-oriented gurus, they find what they need, instantly in there. So they break it up into data containers, namespaced commands, data types, and then they've got some examples. So to find your way around, like I said, if you're a good object-oriented programmer, you can find your way pretty easy. If not, I always like to try and record what I'm doing and then look up the objects, methods, and data types that they are in there to find my way. they do group the data containers and the namespace commands by the applications they belong to. And so I'll bring that index up, and then I'll use Control F to search for what I need. And then they've got some examples that also show how to use these things. And the API is not known as the most concise way to carry out actions within the interface. It's so verbose, and I get funny looks when I say that. And okay, I learned Fortran as my first programming language. I still make all my parameters less than 8 characters, or 8 characters or less. So I'm old-fashioned, but most of what you need is documented in there. Some things you may want to do may take 1 to 2 lines, or may take a lot more. And it's because it's object-oriented, and also because this API is growing from journaling. So, behind the scenes, there may be 4 or 5 routines that are called when you click on something, and each of those routines generates a line of code. So that's kind of why it works that way. I hope to see, and they've kind of hinted they will do this if they have time, to take some of this stuff that's verbose and turn it into maybe 1 line rather than 5 lines. In the material property is a good example. Why can't I just use 1 line to point to my system and then specify the name of the material, the name of the property I want to change, and the new value. And somebody just needs to write that and combine those multiple lines into 1 line. Okay, so that's the basics of the API. The bulk of it is get in there and look at the help and look your way around. So let's go back. And here somebody points out that obviously is a Python scripter. He says the example you gave earlier, changing the density, could have been written in 1.0 command, but it would have been more difficult for Ansys to generate that way. That's exactly what I'm saying. You're exactly right. So hopefully they or somebody in the user community, and we'll go over this example in detail now, would turn this into 1 line and share it with the community, and now we can just do it in 1 line. But because of the way the GUI works, that's the way it is. And it makes sense. I understand that, and it's okay. And as time goes by, the stuff we do a lot, we'll go ahead and simplify and make better. So I built this by recording. And like I said, this version here is the Ansys version. It's version 13. System is System 1. That's the name, so I know that's the name of my system. And then this is a very typical thing where you use a call that's part of the API, this get system is part of the API, and you say some sort of an identifier, the name. Okay, let's use the name, and the name is the string. So it goes internally and looks for something with that name and returns it and puts it in this container called System1. And you'll notice the nice thing is I don't have to declare variables. I don't have to declare types. This thing I like about Python, it is case sensitive, and it can be a little picky with syntax, but not as much as most programming languages. And then I take that object, System1, and I say, okay, I want to do something with System1. What do I want to do? I want to figure out within that system, where do I store my material properties? So I use the get container, and if you remember looking back at a system in Workbench 1 in the project page, there's engineering data, there's modeling, there's results, there's parameters. In this case, I'm going to get engineering data. So I've got that object. Now I'm going to use this API call, get material, which is unique to an engineering data type data object. And I'm going to tell it, I'm going to identify it by structural steel, put that in material 1, and then say for the object material 1, I want to get a property that's called density. And then I'm going to say material property 1, I'm going to use the set data call. The thing I want to change is density, and I want to change the value to 8,000. And this is all documented, and I really recommend you start by going through something this simple and looking it up in the help and understanding what's going on. So I used for the next example, I actually grabbed something from the help. It's kind of a neat example. It does a lot of things. And what it does is it goes into projects and takes the design modeler, the CAD file the design modeler points to, and changes what it points to. And it shows you how to parse through systems in a project, change the geometry file attached to the design modeler, do an update, extract parameters once you've done before and after that, And then also, if you made a change, you don't want to overwrite your old project, save it to a new directory. I like it because it shows how to parse a project, how to do file I/O, and it's also got a neat thing about error handling. Again, if you're not a Python wizard, there's some neat stuff you can do with Python for error handling, and it shows that. So I've got multiple pages here. We'll go through it and look at them. And this, again, is in the help as well. So the first thing you got to do is tell Python with an import command that I'm going to go ahead and do some OS functions, so bring in my module for OS. And then create a helper function called writeParams that takes log file as the argument, and go through all the parameters that I currently have. So for every parameter in parameters, get all parameters. So this is an API call that Ansys gives you. Create a parameter string, parm string. Start with a blank, give the parameter name, put a colon, do the display text, which is the name of the parameter, and then the value, and convert it to a string because it comes back as a real number. And then write that string with a carriage return to the log file, and then flush the log file so it actually writes it. So this is a Python thing you got to do. And then that's the end of this little helper function that we wrote. So if you're new to Python, something I want to point out that I didn't know, that I always forget, is tabs tell you when you're inside something that's above it. You notice there's no actual end sub or anything like that. It's just the fact that I've got something on the first line here that says, oh, okay, well we're back to the main routine here. So the first thing I'm going to do is use the helper function absolute user path name and set that. So I basically take demo, script example, original, and append it to the current path. And then I also create a directory structure. Not the structure, I shouldn't say it. The name of the directory, and put it in a new directory where I'm going to put my modified guy. So it's already in original. I'm going to stick it in modified when I'm done. I'm going to create a new geometry file, and it's going to be a database file from Design Modeler, and it's in these directories here. This app's user path name you'll use a lot. That way you don't have to keep putting in the path to where your files are located. I'm going to open up a log. Same thing. I'm going to open up in the same path. I'm going to call it geometry place. I'm going to open it for writing, and create the new directory if necessary. So I'm going to say if this doesn't exist. So this is an operating system Python call. If the path, this is part of the OS, take a look at the path object. If it exists and it's called new directory, if it does, go ahead and make. If not, actually, make a new directory. If not, if it does exist, just keep going. Oops, don't go yet. And then the next thing I'm going to do is I'm going to create a blank list called project list. And I'm going to say for everything in this original directory, for every file in this original directory, because I'm going to use the list directory command, if the file name ends with Workbench project, then add that to project list. So I'm going to append the file name to project list. So these are all standard Python things. So the next page here, for every project file that I find in project list, so I created a list of all my project files. Now I'm going to loop through all of those. I'm going to open the project into Workbench and clear any starting messages. So again, the project path is OS path join, the original directory in the project file. So I'm going to make a pointer to that. Then I'm going to go ahead and write processing project in whatever this file name is to my log file. And then I'm going to open the project. So this is a call to Workbench to open it and clear all the messages that are currently there. Then I'm going to use my writeParams helper function, which we did, remember, up here, writeParams, which writes all my parameters to the log file. I'm going to go ahead and call that. So before I make my change, write all those. Then I'm going to walk through each system in the project and replace the geometry file. And this is one of those cool Python things that I'm not as familiar with as I should be. It says get all systems is a call that you can make using the Workbench API, and it says store the system name in system, the system pointer in systems. If it worked, say geometry is equal to that system get container component geometry. So try that, and if you get an error, it says no geometry replaced in the system, and it gives the name of the system. So you basically go and try a command, and if it fails, do one thing. If it doesn't fail, do else, and that else is set the file to your new geometry file. That's kind of a cool way of doing it. And now I've done that, I'm going to update my system. So I've looped through all my systems, right, in this little loop right here. And remember, there's no end. It's all done by indentation. Update it. Now I'm going to go ahead and say, if the project is up to date, if the update was successful, go ahead and write those parameters using my write params. If it wasn't successful, say, hey, it wasn't successful. Go to my messages. That's why I cleared the messages at the beginning, and grab them for every message and stick those messages in my log file. So this is a great example of error handling. I've done an update in a Workbench 1 application, right? It's not scriptable through this tool. But I can go ahead and grab these messages from it and stick them into my log file and see them. So I've done all that. I'm going to go ahead and save it in the new directory and then close out my log file with the close command. Put a carriage return there and close it. So that's a kind of detailed look at it. Another example we did in a focus article called Driving Workbench from Excel, and you can go ahead and take a look at it on the blog website. And the first example is an example in the help that you should look at, and then we actually wrote an example. It's a little tower tool where you specify the length, width, and height of a tower and a pressure on the side of it, and it calculates the maximum bending of that as well as the natural frequencies of it. So take a look at the article to learn more about it. And it's a good example of how to run Workbench in batch and also how to use IronPython's Windows connection. But I wrote it, so it's not good Python. And based on some of the questions, I know some of you know Python really well, so don't laugh at me. So the first thing you do is you bring in that Microsoft interoperability stuff with this import CLR and add a reference to Excel. And I can do Python or PowerPoint, or I can do Word or whatever I want. So like one thing you might want to do is automatically take all of the images in a directory and stick them in a PowerPoint, that sort of thing. And then I go ahead and add the system.io stuff and the date time stuff because I'm going to use that as well. I get my project directory, and I set my current directory to that project directory, and I open up a log file. So I'm kind of avoiding some of the things you saw in the Ansys example by grabbing this information and making that my current working directory rather than specifying the full path every time. And then I go ahead and write a header to my log file. And then I use an Excel call. So the calls to Excel are all documented in the help for the interoperability stuff, the CLR stuff. If you go to IronPython, you'll see them there. So I get the active object to figure out, okay, well, where's my open Excel application, and make it visible. And then I say, whatever my active workbook is, let's store that in a variable, and whatever the active worksheet is, let's store that in a variable. So those are objects I can now do stuff with. So first thing I'm going to do is go into Excel and grab the value of the cells that we want data from. So for the worksheet and the range name length, if you read the article, it talks about how I use names instead of actual cell references to make it a little bit easier. So I grab all the values for all these. And again, this could have been done with a loop or something, a list or something like that. And then I'm also going to see if they want to save the project when it's done. Then I go over to Workbench and I do the same thing, right? So I have this parameter object in Workbench, the parameters for the project that I'm currently in. Where did I define that? Up here somewhere. Maybe it's given. No, I guess it's just a given. So I go to parameters, get parameters, and I call it P1, and I store it in there. P2, store it in here, P3, P4. So you use the actual name that Workbench gives the parameter, not the name you give it to refer to it. Then I get this deflection parameter. It's an output value as well. And then I set the values of the input parameters. So remember, I got the objects. Now I'm going to go ahead and set them, length param, width param, height parameter, and pressure parameter, by converting what I got out of Excel, right, length up here, to a string and sticking it in there. And then we'll go ahead and change the output value to calculating so that they don't, so while it's actually running Workbench, it says calculating instead of the value from the last run. So if it crashes, I don't have a mismatch there. And then I go ahead and say updating project to the log file, and I execute the update command. And if it says save it, I'm going to go ahead and say yes, and then write to the log file and hit the save command. So I save the changes that I've made. And then I assign the values of the Excel deflection cell, output deflection from Workbench. So I go in and say, so I do this all in one command. Instead of doing it in multiple commands, I say go ahead and get, for the parameters, the value for the deflection, and I go ahead and set that in Workbench here. And now go through the value of each natural frequency in Workbench. Let me make sure I got that right. That doesn't make sense to me. Assign the value of the Excel deflection cell output deflection from Workbench. So worksheet range, yeah, the max bending distance is equal to the value from Workbench. That's correct. Yes. Now go through the value of each natural frequency in Workbench and set the corresponding cell in Excel. This again can be a loop. So I go and I get, for the parameters values, these different values, and I go ahead and set them in Excel. And I'm done, and I write to my log file that I'm done, and I close. So that's an example of how to work with Excel using Python in Workbench. So I almost think that I'm missing a page in here. Did I scroll too fast? No, I didn't. So this assumes, I misspoke. This assumes that, I said that it would show you how to run Workbench in batch. It actually doesn't. It's a different example that we'll have to come back to at another point. This actually assumes that Workbench is already up and running, and I'm running this from within Workbench, not from within Excel. That was a different example that we did in a different article. So I got confused there. Sorry about that. So those are the examples that I have. There's more in help, and use them as much as you want. Somebody want to know if I could show the APDL interface. I can actually show that from the help. Let me do that. I think I still have it open. I'll share this once I find it. I'm not going to make you watch me fumble. Yeah, there it is. Go to WebEx. I can say share this app. Share this app. Okay, so you should be able to see the help section. So this is a fairly robust documentation they have in here. So I go to Workbench Scripting Guide, using scripting in Ansys Workbench, and then uses examples. And I've got mechanical APDL setting commands. So you can see here's my script, my APDL script, right? And then here's my Workbench. So it basically goes in, creates a model, basically creates a block, show properties, element type, constrains it, puts a pressure on it. They like putting pressure on towers as much as I do, and solves it and does a finish, and then retrieves the results and does start get to get some results. So they do the same thing. They import the OS module. They go ahead and get the location of the pointer basically to that input file that we just looked at. And then they provide a list of the bar lengths that they want to do. So they're going to basically loop through these different values, run that script for each of these values. Open up a log file, always a good idea. They're going to start a new project. This is a good example of how to create a system. They reset it. They grab the template mechanical APDL, and they set template 1 with a create system command equal to system 1. So they store it in system 1, and they use the create system method to go ahead and create a system. that's of type mechanical APDL, right? Because that's the template they used. And then they read the input file into mechanical APDL setup. The system1 container is the setup. Remember we talked about containers. This is a setup container. And add input file is an action you can take on that container. So they specify the path to that file. And they go ahead and use the ability to grab parameters. So they create a workbench parameter from two of the mechanical APDL parameters in the input file. So they say publish mechanical APDL parameter. So this is something that's in the APDL API. The workbench API is to say publish some sort of a parameter that's in mechanical APDL. So publish Z-length, right? And then they also go ahead and get P1, the pointer to P1 in workbench. And then they say, using that input file, publish the mechanical APDL parameter, right? Name equals out. Is direct output is true, so it's only an output parameter. And you have to look at the help to learn these a little bit more. There's a lot of options in there. And make a place to put it, P2. Save the initial project definition, and then loop through the provided lengths. For every Z-val and Z-values, they're going to go ahead and set parameter 1 to Z-val, write it out to a file, and they're going to do an update. Remember, this is that try thing. So they're going to try an update, and if it fails, they're going to put update failed, and if it's exceeded, they're going to go ahead and put the value of parameter 2 into the log file. And then generate the name of the CDB file to save. And if it exists, let's see, yeah. I'm not quite sure why they're doing this. They're giving it the name of the length and then replacing backslashes with forward slashes and things that you have to do for the operating system. And then delete the CDB file if it already exists to prevent mechanical from prompting us about overwrite. Oh, so go ahead and get rid of it afterwards. And then they're going to, I understand what they're doing here. Can't remember this example now. So first they go and they loop through, right? So they went ahead and did this stuff. They went ahead and did the update. Now they're going to go ahead and just send a command to mechanical APDL to write out a CDB file. So this is how you just send one command. The other one, they created a file, this upper part, they create a file, and they run mechanical APDL with that file as an input deck. Then they just say, okay, this is how you send one command. So if you want to do like a star get, you would use this send command. Glad you asked me to show this to you because I should have put in the examples. I forgot what a good example it is. Then do a save, and then close the log file. And this is what it looks like when you're done. So really good example of how you can do some fancy stuff running Python through the project page, through a system in the project, to run mechanical APDL. You can't have your APDL and your Python coexist in the same world. So some suggestions and recommendations. If you are a Python expert, ignore this slide. If you are not, it's pretty easy, but it's different. Go to python.org. That's where all things Python merge or come together. I really like their documentation part of the site. They've got some great tutorials, and that I think more than anything, those tutorials got me over my hump with Python. There's also a ironpython.net/documentation, and what's great about it is the documentation for how to interact with Excel and all these other tools, these .NET applications. And the sample section had some great examples as well that I used to kind of understand things. There's a wiki.python.org that is a community documentation site, and the beginner's guide I thought was too basic, but maybe it's worth taking a look at if you've never seen Python before. And what I found really useful was this beginner's errors, and I did make some of these. And then also you want to know what you have to write your own stuff, what you can reuse that exists in the community. Go to wiki.python.org, moin, useful modules, and they'll show you a whole bunch of the most common modules that are out there. You can always Google as well. And there's a ton of books out there. Just pick one that looks good. I can't recommend one. They're all pretty good. So I do recommend that. The current slide. So tips for scripting. I already mentioned this. Use record, so you don't have to hunt through the help to figure out what objects and methods and things you need to use. I like to use the console and cut and paste into it. Get to know the Ansys help. It's pretty good. And then somebody actually brought this up, and I appreciate they did bring it up, but I saved it for now. Get a Python-savvy editor. I use Vim, which is a VI editor for Windows, because I'm old and I know VI. Somebody recommended an Emacs. The Emacs editor obviously does it quite well. There's some tools out there that are more for those of you who don't have gray hair and don't use Vim or Excel, or excuse me, Emacs. There's a couple of really nice environments that have context-sensitive help, and they complete your auto command completion and things like that for Python. So do a Google on Python editor, and you'll see all those. But for small stuff, I just use Vim. And then also write your code in small chunks. You don't write. These are typical programming suggestions, but it's really true when you're trying to interact with someone else's interface. Is write real small modules that you can debug and test on their own without spending 4 days to figure all this out. And if you go to any of my webinars, I always say crawl, walk, run. Don't bite off more than you can chew. Keep going. Somebody recommends idle. God, I forgot about idle. So idle is a nicer. I think it was based on Emacs. I'm not sure if it was or not, but it's a more modern text editor that works really well with Python. Forgot it was out there. Now, you can control your journaling. So, we talked about turning record on, but also by default, I think it's default, or I don't know if I turned it on, but I think by default, it actually records a journal file of everything you do in the user interface. And you can go into Project and go to Tools, Options, Journals, and Logs, and you see this thing, a record journal file, and I think it's on by default. And it sticks it in this app data directory, which no one ever looks in. That's why I don't think any of us know it's there. And it keeps it for 7 days. So when you start up Workbench, one of the reasons why it sometimes can be slow starting is it goes out and says, oh, let me check this directory and see if there's anything older than 7 days. If there is, I'll get rid of it. And that's why you haven't got a disk full error message, because you've been using Workbench for 5 years and it hasn't filled up yet. So that is written there. And you can specify a default directory for that and the number of days. And by default, I believe it's on. If Python is okay, so how do you get support? So if PADT is your support provider, call us. We'd love to help you. We want to learn more, and the best way for us to learn more is to help others. If you're not lucky to have us as your support provider, or if you, actually, I should have said in here, my sales guys will yell at me. If you want to pay us, we'll help you too if we're not your support provider. We're very eager to help people learn and use this capability on a consulting basis, so do consider that for us. You can also ask Ansys tech support if that's your support provider, if you have another channel partner as well as your support provider. If you've got a clearly defined question, they'll probably help you because they want more people to do more Python. It may not be tech support. It's more of helping you do your job, so they may in other times say, oh, this isn't tech support. But I really think they're eager to help people learn this capability, so don't hesitate to call them. Also, I'm starting to see a few posts on using Python with Workbench on xansys.org, so do post there. Okay, so there's a few questions. Actually, one here. Any way to create your own user interface using IN Python? Yeah. So if you go to the modules that are out there for GUIs with Python, they work with IN Python. So you could write a little dialog box that pops up and asks the user for information, and then goes off and runs Workbench. One way that I thought could be really common, a really nice thing, is you have an optimization tool that doesn't talk to Workbench already. That's maybe an in-house tool or an academic tool. You could write a really nice little GUI using Iron Python that talks to Workbench, that either runs it in batch or works with an interactive section of Workbench, and does some cool stuff with the parameters, right? Because that's what you need for optimization. So you can modify and update your systems, change your parameters, kick off some runs, bring them back. So I think that would be a really cool thing to do, and use the UI to create a tool. I'm going to write that down. That would be a great focus article, is a simple dialog box. So if you want to prompt the user from within Workbench to enter some information in, or maybe do a graph. So that's a great question. So before I give you the sales spiel to end this session, I'm 2 minutes over. Any other questions anybody have? You can go ahead and type them in. I'll let you type while I do a thank you here. Does this language work with Ansys Workbench 12.1? Very limited part of it does. They released it in 12.1, actually, this tool, but we didn't talk about it because it didn't do a lot. I think material properties were documented. That's about it. And journaling didn't always work. So, but give it a try. I think it works more than I give it credit for. So I would definitely give it a shot. The best way to try is to go to that tools, scripting, record, and see what happens. So give that a shot with 12.1. But hey, 14's coming out in 2 months, so it's time to get to 13. So thank you for coming. We really enjoyed it. This was really a fun one for me. I was traveling, so I didn't do as much as I wanted to. I wanted to put another example in there. Maybe we'll follow up with some stuff on the focus. Please consider us as your partner. We're not just here for webinars or things like that. We do a lot of other stuff: training, mentoring, consulting, customization, and if you're lucky enough to live in the desert Southwest or in the mountain region, we'd love to sell you a seat of Ansys or more Ansys. We also do printers and systems from Stratasys. Like I said earlier, if you're looking at buying a new computer, I think you got a quote from Dell, email it to us. See what we can do competitively. I think you'd be surprised at how much cheaper we are. And we build these systems for simulation. So one of the reasons why we're cheaper is we throw out all the crap you don't need to do simulation. And of course, we do product development and rapid prototyping as well. So we're here to help you, so let us do it. So if there's not any more questions, we'll finish a few minutes late, and hope to see some of you at the next one, and have a good rest of the month. Thanks a lot.